Okay, so we're working through the fluid pump that is going to be moving the fluid around to move these pistons. And maybe we'll go over to the robot that is waving to us. And we can work through what kind of pressures we need. I've set a pressure at 400 pounds per square inch, which is the top pressure. And obviously, you're not going to need to use that pressure unless it's necessary. You can see there are certain pistons that are increased in size. These are the anti-gravity pistons. These are the pistons that lift the robot up in the air. Against the force of gravity. And so some of the pistons of the robot are larger in size because they're doing the motions that move the robot or the weight of the robot against the force of gravity. And when we had the robot walking along, we had parts of the cycle of the robot where the robot had its weight on one of its legs. So you can see here that the robot's weight is on its left leg. And to the extent that the robot moves itself up and down, or the robot moves its whole body forward, using this left leg, you're going to need the high power side of the fluid because you're moving the weight of the robot. But you can see on the motion where you're just simply taking this right leg that is not on the ground and it's not holding up any weight and it's not really doing anything other than just being in the air, and you're swinging this leg forward. You're not going to need the whole 400 pounds per square inch on your pistons to get that amount of work done. So some of the fluid that you use, you're going to be using it at the high pressure value, and some of it you're going to be using at a lower pressure value. And the next calculation that needs to be done once we've figured out how much pressure we need is to work through. And again, these pistons are like 4 inches in diameter, so the radius is 2 inches and the surface area is pi r squared, and r is 2, so that's going to be 4 times 3 is 12 at 400 pounds per square inch. This little piston right here has a net pushing force of 4,800 pounds, which is, and remember now, you can see that there's an angulation effect of this joint where you're pressing on this upper leg with this piston in a lever fashion. So when this moves 1 or 2 inches, this moves 7 or 8 inches. So you do have some magnification of the resistance force against your piston because you're using lever action, but that's the way human beings work, and it's not a big issue if you have that kind of force available from your piston. The next issue that comes up with is that we know where we're using our fluid and we know what kind of pressures we're using, but we still have to get a flow value for how many gallons per minute or gallons per second or liters per minute of fluid we're going to need to run this robot through one complete cycle of walking.